Welcome back. We are COMP1115, that's Game Programming 1, and the fall 2025 semester at Georgian, and it's week 4, part 2 of our broadcast and recording together. And in the last part, what we did was we were able to go in and basically in Visual Studio here, what we did was we set up our project based on ICE 3. We made ICE 4. Wow, what a lot of work that was. And you might think that, wait, is there not an easier way to do this? And the answer, my friends, is no. There is no easier way, right? In fact, I have to say something else. Unity is also quite challenging to change up and make a new project from an old project and stuff. If I was programming with Android or iOS, same. Very difficult to go from last week's project to this week's project. Any programming language except for the web. If I was programming in the web, instant. I can change instant, redo stuff, and then everything is good, right? But it's not like that here in Visual Studio and C#. We have to do a little bit of a dance, which is what we just did, to make sure everything is good to go. So now back to this. What we want to do is we want to talk about loops. Loops, like I said before we left, I said that the while condition, the way you read this is while the condition is true, that anything inside these curly braces repeat forever until this condition is false, okay? So that's how it works. So then the way it works is, let's suppose, and I'm not going to read all this, this is for your reading pleasure. Again, I recommend you read the slides to help you. So let's suppose this is a situation. We have int x is equal to 1, so we've initialized a variable called x. That's not a great variable name, but let's suppose it was. And then while x, this is the condition, is less than or equal to 5, let's think about this, we're going to loop, right? So the first thing is we're going to print out x. So this is x is equal to 1. So it prints out x. The value of x is currently 1. And then we do x plus plus. X plus plus, if you remember, is the increment operator. It increases the value of x by 1. So now it becomes 2. Goes up to the top, does another check. X is now 2. Is 2 less than or equal to 5? Yes. The condition is still true. We print out 2. Goes back, changes to 3. Goes up here. 3 is less than or equal to 5. The condition is still true. Prints out 3, goes back, makes this 4. 4 is less than or equal to 5. The condition is still true, prints out 4, and then makes it to 5. 5 is less than or equal to 5. Less than or equal to 5 is true, right? We print out 5. This becomes 6. Come back up here. 6 is not less than or equal to 5. The condition fails. Then it skips this. It skips the curly braces altogether and goes to the next line. That's how the loop works, okay? So it kind of goes in, keeps doing the same statements over and over again, executing those statements until the condition at the top is false. That's how loops work. Okay, that's the while loop. It's one of the first loops we should learn how to use. Very common. One thing, loop is a powerful construct, and it's going to save us doing like 100, let's say 5 write lines. Write line 1, 2, 3, 4, 5. Imagine I had to do 5 of those. Now I just do 1. And I have another statement that increases. There's a lot of noise, though, for increasing the loop, and there's some other looping structures as well. One thing is that you can have something called an infinite loop if you're not careful. Infinite loops are one of the biggest things that programmers face. They're like, what the hell? How come this is going on forever? Because your condition is always true for some reason. Maybe it's the way you worded it. Maybe it's you didn't increment it. Maybe you forgot the x plus plus, you know? And it's never going to be false because it's going to keep going to the top and keep printing out the same number over and over again, right? Because you haven't incremented it. You have to make the condition false somehow for it to fail and stop looping. You have to do that. It's not going to do it for you, right? You have to create that condition somehow, right? So if by chance you said true here, like if you ever actually did this, this is like terrible to do, but if you actually did this, well, it's not always terrible. There might be a reason why you want to do this. But if you did true, that means it's always going to be true. It doesn't matter what you put in here, and it's going to keep doing this forever, an infinite loop. So your program would literally run out of memory at some point because it's going to keep on incrementing, and making that number bigger, 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 bigger until there's no more room for that number, and it's going to crash. Okay, that's what's going to happen. So that's how infinite loops, it's a bug a lot of times. So keep that in mind. I want to talk about terminology here for a bit. It's not in the inside the PowerPoint, but I want to talk about it anyway. I'm just going to go back up to the proper loop. Let's suppose I look at this loop here. The first line here I want you to think about this initialization is I want to call this the sentinel variable. And the reason why it's a sentinel variable, it's the thing that is a dependent, it's almost like a dependent variable. The loop is dependent on this variable for it to fail, right? That means if you have to initialize it because that's the variable we're testing against. You have to be able to do that. It has to have some kind of value. Now, what about this? What about if my variable, instead of it being 1, what if it started off as 6? What happens then, guys? What do you think happens then if it starts at 6? Can someone tell me what goes on? Yeah, it's so never starts. Actually, what happens is it does do something. It goes int is equal to 6, then it goes to the while statement, and it says, it checks the condition. It actually checks this. It says, hey, is 6 less than or equal to 5? No, and because it's not, it skips this. That's what it does, okay? It skips it. If this condition fails, just like an if statement, if the if statement fails, if the if is not correct, it'll skip that and go to the next thing, okay? There is nothing else with while. You can't do like while else. You can't do that. It's like while is a loop. It's nothing to do with if else, right? Now, one thing I have to say that because while has its own scope, because we have a curly braces in your mind should be a box. It's a scope. That means I can declare variables in there. I can have if statements in there. I can have other while loops in there. I can have other kinds of things in there. It can go deep. The rabbit hole can go deep with scopes. Okay, it can keep going down, down, down. Yes.
You can put a while inside of the if.
Yes, you can put a while in an if. You put an if in a while. You can do all kinds of stuff. That's what I'm saying. These things that I'm giving you are building blocks for building massive programs, right? I mean, think about this. You can do a lot just with what you already have if you're a little bit creative. Okay. So that's the first thing. So that's the first construct, the while loop. Okay. The other loop is the do while loop. I want to talk about this. So this is less used. It's less common. I got to say this. And the reason why it's less common is there's a bunch of different ways to do this. So remember the while loop, if the condition fails, may never run, right? May never run. But what if you want to run a loop at least once? This is the way to do it. You basically have another construct called a do while. Here's a do while loop. So do while, do is a keyword, right? And then now you have the scope of the loop, and then you check the condition at the bottom instead of the top. So you're like, hey, do this while this condition is true. Notice the condition is more complex, right? Just like an if statement. Player's number, let's say here's player's number, is less than 0 if it's less than 0, or player's number is greater than 10. So if it's nothing, if it's less than 0, like a negative number, or if player's number is greater than 10, so it's outside of, it's not 1 to 9. If it's not 1 to 9, then it's going to be, if it's not 1 to 10, then it's going to fail. So let's take a look at this. Console write, enter a number between 0 and 10, right? So we get a console read line, right? Player response is the console read line. We convert it, player response, to the player number, right? And if that conversion is within range, 0 to 9, then what ends up happening? What happens if it's between 1 and 10? What happens? It loops. It goes back up to here and goes back down, asks you for another number. It'll keep asking you for a number as long as you give it numbers between 1 and 10. It'll keep asking you for numbers, right? As soon as you give it a number that's negative or a number that is greater than 10, it will fail and it'll skip down to the next line. So kind of a weird construct, a weird way of doing things, right? But remember, when you see something and you're like, why do they need that? Somewhere down the line, my friends, somewhere, right? This thing solved the problem. Remember, the problem with while loops is you may never run. Here, it always runs once. So those are the two options that you have here, okay? So that's the second type of loop, do while, okay, do while loop. And then the most popular loop that we got to talk about is the for loop. Okay, the for loop is interesting because this is the while loop. Okay, here's the while loop. But there's a lot of stuff going on here, right? You've got the sentinel variable. You have to update it down here. This is called loop management. I have to manage my loop. I have to make sure that it's going to terminate somehow. Otherwise, it's going to be an endless loop, right? So we want less overhead for a loop. And if you want something that you want to run for a certain number of times, let's say, for example, you know 100%, you only want to run this loop 10 times. You know for sure. It's a finite number of times. then the for loop is for you, right? The for loop does something that looks like this. It has 3 parts to the for loop. Okay, it's still the same loop. You have to use the for keyword, and here it is. There's the initialization statement. For example, something that initializes the sentinel variable. Then there's the condition to evaluate, which goes here, separated by semicolons, by the way. And then finally at the end, some kind of updating action, okay? And it all happens at the signature, at the declaration of the loop itself, right? So that's the for loop. Now that's the structure. Let me show you what it really looks like, right? So you understand what it looks like. Here's an example of a for loop, very common. The same thing that we did earlier, but instead of having an extra line for initialization of the x, and instead of updating the x manually inside the body of the loop, we do it here on the statement above. Let's take a look at this. So here in this initialization, I'm just going to go in here for a second, 1 second, so you can see it. Here is initialization, right? I initialize my sentinel variable to x, or x to 1. So it starts at 1. Here's my condition. Is 1 less than 5? It evaluates right away. True. It's true. Then, if it is, increase x right here to 2. So x becomes 2, right? But it's going to not increase it now. It's going to do it at the bottom of the loop. So that's something to know. So x is 1. 1 goes in there. And then at the end, it gets updated. So instead of it being down here, x plus plus, the management happens all at the top. You're telling it what to do at the top of the loop, okay? Here's positives about this, okay? It's really great if you know exactly how many things you want to loop through. If you have 10 numbers, 100 numbers, 2,000 numbers, 10,000 numbers, whatever, or even 1 number, for loops are fine, okay? But if you don't know how many you have, for loops are not fine. Okay, for loops are not fine when you don't have a predefined number of loops. While loops can keep running until you tell it to stop, right? For loops can only run the number that you tell it. It has to have a terminator. You have this, my friends, is how long it's going to run for. 5 times, 6 times, 10 times, whatever it's going to be, okay? So that's the problem. The number that you want to think about is, so each one of these constructs has a reason for living. Let's try some of this stuff out in code, okay? So I want to go down to Visual Studio, and like we normally do, I want to do a couple things, right? Let's comment some stuff out, right? So here's a way of commenting out everything. So I want to comment out everything that's underneath the character's name here. So we're going to go here, and we're just going to say comment. So that's going to be like the first part, right? And then way at the bottom, all the way, please remember that there's a comment. Way at the bottom, just down here, right, we're going to do the other side, right? So what we want, right, is for these 3 braces, these 3 braces, curly braces, the closing curly braces to be open like this. And then if I go to the top, you're going to see that there's 3 curly braces that are open at the top here, okay? But underneath main, there's nothing now, okay? There's nothing. Everything is commented out underneath the variable declaration for you, okay? So everything inside main is commented out. So this is a good place to try some stuff out. So way at the bottom now, where things are alive, after this little thing here, let's try some loops out. Let's make that loop happen. So I want to do a while loop. So I'm going to do that int, right? We're going to say int. I'm going to make this bigger so you guys can see it. Let's try this out. Int, player number. And I want to initialize it to 0, okay? Let's try that out. Int player number is 0. And then I want to do a while loop. So while player number, right, is less than 10, let's say less than 10, right, then I want to loop. And I want to do a console.writeLine. Let's try this out. And print out the player number. So we'll say something like this. You are player, and then in curly braces, player number. It's going to say you're a player 0 to whatever, but that's what it does right now, okay? Take a look at that. Now there's some underlines here. One of the underlines is this one, and it says, expression is always true. Player number is less than 10. Notice that? Here's a question for you. Is this is this ever going to increment? What am I missing here from this while loop? And the pluses. Okay, there's a couple ways we can do this. We can use x plus plus, like we did before, right? Thanks, Allison. We can do x plus plus, but let's do something more interesting. Let's do player is equal to player number plus 2. We can do whatever we want, right? Okay, so now I want you guys to predict the behavior. By the way, player number is equal to player number plus 2. Is there a better way to write that? What's a shortcut to write player number is equal to player number plus 2? First of all, what is this going to do to player number? Let's do a little bit of a quiz. What does this do to player number? Yes?
It adds 2 to what has been.
It adds 2 to the current value of player number, right? Is there a quick way to do this, a better way than just player is equal to player plus 2? How about the people online? Anybody online? Player number is equal to player number plus 2. Is there a shortcut to writing this thing? No, plus plus only increments it by 1.
What is our goal?
I want to increase player number by 2. Connor says player number plus equals to 2. That's correct, Connor. Thank you. So this is like saying, equivalent to saying something like plus equals to 2. That's the shortcut way of adding 2 to player number. Okay? Okay, cool. So we're adding 2 to player number. Here's a question for you guys now. What am I going to see when I output? What is my output? Don't run it. What am I going to? I want you to predict my output. What am I going to see in the console? So it's going to go 0. It's going to print out 0, and then 8, and then it's going to go. Is it going to show 10?
Oh, no, it'll stop when it reaches 10.
Why won't it show 10?
Because it has to be less than.
It has to be less than 10, I said, right? If I said less than or equal to 10, will it show me 10? Oops, less than or equal. Does it show me 10? All right, so let's try this out. Let's see if it shows me 0, 2, 4, 6, 8, 10. Is that what it's going to print out? All right, so let's see what happens. And again, if your project doesn't run or somehow you commented out the wrong things, it may crash your code. If it takes long like this, the reason why it might take long is I'm rebuilding everything and I'm removing everything that I had before. So this is what you should see. Oh, look at curly brace. Like I got a $sign in there. How come I got a $sign? What happened? What did I do wrong? I put this extra $sign in here. I don't need that $sign. Let's try that again.
I commented everything out, but it's still running the entire program.
Well, that means you didn't comment it out, did you?
It's all green.
I don't know. Something is up with your project. Remember? So I don't know which one. Which player are you looking at? Are you looking at the one that you're running, or the one that was being run before, dude? Like that's what I'm saying. You have two different folders, right?
Can I not remove one of them?
Yeah, but which one? Which one? Right? So that's a problem. Yeah. You're gonna mess yourself up. So notice, yeah, you might, but go ahead, try it. You are player 0, 1, 0, 2, 4, 6, 8, 10. Okay, what if I wanted to here's something else? So I did 0, 2, 4, 6, 8, 10. And if I didn't have this, up here somehow, here's something I want to try. What if I didn't test for this, but I tested something like this? If I said something like, if it's as long as player number is greater than 0, right? Greater than 0. If I did this, is it going to run? Ever? Player number is greater than 0. Will this run?
No.
Why not?
Because the player number is already 0.
Player number is already 0, which means my termination condition is true, which means that, or this condition won't pass, which means it's going to skip everything. Right? Be careful about this. This is all logic errors too. There's no syntax error here. This is whatever you've written here is correct for the computer. It's doing what you're telling it to do. It may not do it what you want to do. That's a logic problem, right? Maybe what I meant is that it's greater than or equal to 0. Now, what about that? What's going to happen there? If it's greater than or equal to 0, what's going to happen? People online can answer too. What is going to happen to this? So Michael says endless. That's right. It's an endless loop or an infinite loop. Why? Let me show you what happens. Let's try it. Let's make an infinite loop, right? And let's see what happens. Okay, we have to look at that infinite loop. Look at that. Oh yeah, it's counting pretty damn fast, right? And some of you may even count faster than this. And what it's going to do, it's going to get to the point where we run out of integers, right? And it's going to keep going forever. You can exit out of here, please. Don't wait till it blows up, all right? But at the end of the day, this is an infinite loop. And we don't want to have this infinite loop. If you're getting an infinite loop like this, you've done something wrong inside your looping structure, okay? The other one to do, the other thing we want to try is the for loop. Let's rewrite this as a for loop again. So if I was going to do it as a for loop, I would have the following. I would say for, right? And we want to type in int is equal to 0, semicolon, while, let's make it player number again. We'll say player number, int player number is equal to 0. There we go. While player number is, we'll say, less than or equal to, this time, 10, right? Then we want player number plus plus, okay? So that's going to do that. Now what is this going to do? What's this going to do? If I run this way, what do you think it's going to do? Player number is equal to 0, so that's my initialization step. It starts at 0. Player number is less than or equal to 0, less than or equal to 10 is my condition. It's going to check that for every single loop. Every time it loops up to the top, it's going to check that condition. And my player number plus plus. What am I going to see before you actually do it? Predict it for me. Is it 1? What am I going to get? Yeah. Tell me what it's going to be.
It would be 1. Start off as 1 and then
1?
2.
Okay, let's see what happens. Well, here's something. Look, we have this. We still have this. We still left this in here. Okay, so
Yeah.
this is interesting. So it's going to start off at. Is it going to start off at 1?
No, it would be 3.
Is it going to start off at 3? Let's see what happens. So when we run it, some people are answering already online, right? 0369. Someone said. The other person said 03579. Let's see what happens when we run it. 0369. Okay, why did it do 0369? Because it starts off at 0, right? Then it prints out 0. At the end of the loop, it's going to increase it by 1, whatever it is. But I've already increased it by 2. So it goes by 2, so it goes from 0 to 2. Then it increases by 1 because of the loop management. This is this part. So it goes to 3. So it goes 0, 3. And then now it's 3. It tests to see if 3 is less than or equal to 10. Is it less? Is it true? It's true. So now it's going to print out 3, right? And then it's going to increase that to 5. Then loop management is going to increase it to 6. And then it's going to test to see, it's going to print out 6. First it's going to test to see if 6 is less than or equal to 10. If it passes, it's true. Then it's going to print out 6, increase it by 2 to 8. Loop management is going to increase it to 9. It's going to check to see if 9 is less than 10. It is. It's going to print out 9. It's going to increase it by 2 to 11. And then loop management is going to increase it to 12. Right? It's going to come up and say, is 12 less than or equal to 10? It's going to fail, and then it's going to skip all this. So that's why it's 0369. So I know this is exhausting. I went through an exhaustive case for you, and I wanted to record this for you as well, because if you ever have a doubt as to how loops work, I recommend on your free time you experiment. You do some experimentation and see if you can make the loop count the way you want it to count. A good example of this is if I want to count by I want to add stuff up in the loop. I can add things up in the loop too, right? Okay, here's something. I want to make a loop, right, that actually does the Fibonacci sequence. Do you guys remember the Fibonacci sequence? So the Fibonacci sequence goes like this, right? It starts off at 1, and it goes to 1, and then 2, 3, 5, 8, 13, 21, 34, 55, and 89. So what it's doing is doing this. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 and 5 is 13. 13 and 8 is 21, and so on. So it takes the previous number, right? It adds on the new number. That's the number that it prints out. Then takes that new number, and that's the new number that it's going to add for the next one. So how would I code this crazy one This is a challenge for you guys. How do I code Fibonacci here? By the way, Fibonacci is a number that appears in nature everywhere. It's a natural number, if you will. And the reason why, you can see it in flowers. You can see it in all kinds of places. The universe has Fibonacci in it all over the place, right? So it's an interesting thing. If you ever meet Rui, he's one of our artists, and you talk to him about Fibonacci, he's crazy about it, right? He made a whole game based on it. Okay, so how do we do this? So what's the condition? So this is we'll call this Fibonacci, right? So I'm going to right click here, and I'm going to, when I right click, I want to rename this. I want to refactor rename, if I can. If you don't have this renaming thing, you might have a rename, right? But I want to rename this thing so that it is Fibonacci. So let's do that. So Fibonacci. You can do this manually too. So we know that Fibonacci is going to start with, and we just want to do the Fibonacci number that is going to be this. So, we're going to say, we're not going to have anything in here. We're just going to have the number itself being printed out. That's what I want to do. Remember that right line, here's right line, is going to do this, right? So do I want to do it like this? Do I want to set up Fibonacci like this? Well, it's kind of weird because I'd have to add to it. It has to start at 0, and then I'd have to add 1 to it, right? So that's the first thing. So then this is where Fibonacci adds 1 every single time. This is going to fail. It's not going to do what I want it to do, right? Because this is not what I want to do, right? Let's undo that change, right? I'm going to, actually, let me do that. I'll put the Fibonacci in there, but I want to print Fibonacci out. That's true, this one. I want to print this out, but here I need a sentinel variable that is not the same, right? This will make this the index, okay, instead, okay? So here's index. And if I want the first, so we can't, Fibonacci sequence, by the way, is infinite, okay? The Fibonacci sequence is infinite. If I want the first 10 numbers, right? So if I want the first 10 numbers of the Fibonacci sequence, then what do? I need to set up Fibonacci here first. So int Fibonacci is equal to 1. I'm going to start off at 1, okay? And it's going to print the first number, Fibonacci, right? So it's going to say 1. So that's the first number, okay? Then it's going to go up and it's going to say, it's only going to run 10 times because this number up here in the for loop is independent of my Fibonacci number, right? My Fibonacci number is something I want to compute, right? So now what's the next step? What do I put here for my Fibonacci? I want to add in the previous number, right? So Fibonacci starts at 1, but I want to kind of capture the next number, right? So it's 1, 1, and then there's 2 numbers, right? There's like Fibonacci 1 and Fibonacci 2, right? It's kind of a weird sequence, right, that I'm kind of proposing to you. By the way, this is a great case for a recursive function. But anyways, we'll talk about that later. So previous Fibonacci is 0. That's what we're going to say. Previous Fibonacci is 0. So we have the current Fibonacci and the previous Fibonacci, right? So we're going to say that we're going to take the previous and add it to the current, right? So we're going to say, so we're going to say something like this. We're going to say that temp, like it says here, temporary variable is equal to Fibonacci, right? And then what we're going to say is that the Fibonacci number is equal to the Fibonacci number plus the previous Fibonacci. Is there a better way to say this? We can say plus equals, right? We can say plus equals. There it is, right? So temp is equal to Fibonacci, captures Fibonacci, right? And then what we want to say is previous is equal to temp, okay? Let me explain what's happening here. So temp is a temporary placeholder. It kind of holds the previous value of the Fibonacci number. In this case, 1, right? Now we're going to say Fibonacci is plus equal to the previous Fibonacci number, which is 0. 1 and 0 is 1, right? The previous Fibonacci number we're going to save in temp, right? We're going to save it in temp. And then, or that's equal to temp, that's equal to 1, right? And then it's going to print out the current value of the Fibonacci number, which is going to be 1. We're going to do this 10 times. Let's see how this works. Now, if your mind is boggled, I'm just going to try this out here and try and see what happens. I know. Hold on. I got this, right? 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and 144. That's 10 numbers in the Fibonacci sequence.
I didn't get that far. Mine started at 80 or whatever.
Well, you did it right then, because Fibonacci it doesn't start at 0, it starts at 1. So really what we need to print out is the first value of Fibonacci first. We did 1 plus, this is 1 plus the Fibonacci number, but it's fine. Instead of doing 1, 1, 2, 3, it just did 1, 2, 3. So it counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the numbers here, right? That's what it should give me. But it gave me another sequence. What am I missing?
The first one.
Okay. Let's try this out. Try that one more time. Let's see. How did I get 144 if it counted to 11, but I only wanted 10? What did I do wrong in my sequence? I did it right, but wrong too, right? Well, first of all, I said index is less than or equal to 10, which means it's going to count 11 times. 0 counts as the first time, right? Then it's going to count 1, 2, 3, 4, all that kind of stuff, right? So that's kind of a thing to do, right? I started counting at 0, not at 1, so this is not correct. If I move this to 1, that is a better thing to do. So this, if I only want 10 numbers, then I'm going to say less than 10, because it's going to go from 0 to 9. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, less than 10. 0 to 9 is 10 numbers, and I'm only going to count 10 times. So if I try this again, if I press play, now I should have the Fibonacci sequence as we see here, right? And let's see if I even get 89. Oh, wow, what happened now? What happened? 1, I got 2, 3, 5, 8, 13, 21, and 144, but I'm missing my 1. So let's count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but I started at 2. Oh, man. Oh, man. Well, it also counts where you have this stuff happen, right? If you want to start at 1, then you got to write this stuff up here, right? So if you actually print out the Fibonacci first and then calculate the new stuff, well, then what it does is if I did it that way, you know, then we might get 1, 2, 3, 5, 8, 13, 21, and so on, right? Let's take a look here. Aha. 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. That is 10 sequence in the Fibonacci number. Yes?
Okay. So I probably did this wrong. Instead of changing the previous Fibonacci and switching the console right line, I just replaced name to index and I replaced the 0 with 1.
You could do that. If you wanted to do 1, if you want to go 1 to 11, less than 11, or if you did 1 to less than or equal to 10, it's still going to run 10 times. This is okay too. This is all okay. Remember, you manipulating two things: the initialization, right, as well as everything else that you're doing. Okay. So again, we can make this a little better, right? What happened here? Did it fail? We did it. Yeah, there we go. We can do this a little better because, I mean, again, if you want to think about what I'm doing here, right? I have two variables, Fibonacci and previous Fibonacci, right? And that's the start, 1, 1, and I have two variables that I'm keeping track of, and then I do something like this, and this is called swapping, okay? You're going to see this as an algorithm later on when we're together, right? Where we swap from, let's say from one value to another. That's what we're doing here, swapping, okay? So we're saying, hey, temp, that's our temporary variable. Let's make that equal to Fibonacci. Fibonacci starts at 1, so we're going to hold the temporary value of 1 in here. And then we're going to increment, so we're going to basically save, this is a way of saving our value without losing it, right? We're going to save the previous value here to temp, and then we're going to increment it or add the previous number to Fibonacci to make it the new number, right? That's the new number. And then the old number is going to be saved inside of previous Fibonacci, and it's going to continue this loop until we get to where we want to go. But there's a problem here, right? Here's something that I want to talk about, right? We could have done this construct, we could have done this as well with a while loop, right? Or a do while, or a bunch of other loops, right? So I want you to think about how to do this, and I want you to try yourself to do two different things. Here's a test for you to do at home, okay? Not part of your in-class exercise. I want you to count all the prime numbers, right, from now, for like, let's say that the 10 prime numbers. What are prime numbers? What's the definition of a prime number? Do you remember? A number that can be, so that's your test. If the number that I'm testing can be divided by myself in 1, print it out. Otherwise, skip. Otherwise, skip. And so that's your test. So you keep going, and I want to do that 10 times. I can do it in a for loop. I can count from 0 to whatever, 10 to 0 to 10. And how many prime numbers are there from 0 to 10? 0, right? Can you divide 0 by itself in 1? That's going to fail. 1, dividing by 0 is weird, right? So let's start it off at 1 to 10 or 11. It's up to you, right? So 1 is a prime number. 2, is that a prime number?
No.
Can you divide prime 2 by something else? Yes, it is. 2 is a prime number too, right? How about 3? That's also a prime number. 1, 2, 3 are all prime. 4, no, because 4 can be divided by 2, right? 5, prime number. 6, no. 2 and 2 times 3, 6, right? So 6 is non-prime number. 7, yes. 8, no. 9, no, because 3 times 3 is 9. And then 10, no, right? Then the next one is 11, right? So those are all the prime numbers. So you can actually print those out. So what I want you guys to think about is, can I print other sequences like this at home? There's a bunch of different ones that you can look up and try that out. And I think it's a good practice for you to understand loops. There's no way, guys, that in one single class, I could test out all possible sequences of loops. There's just too many things we can do with them, right? So we're going to do more with loops from here on in, okay? But one thing I want to talk about now, so this is our little Fibonacci program. We talked about the for loop, and what I want to talk about is breaking out of loops. So one thing we can do is, there's two cute little keywords we can use, break and continue. We've already seen break, right, what it does. The switch case breaks us out of that scope. That's what it does, and gets us to check the switch again. So break actually breaks us out of a loop completely. Like, for example, if I said something like in my loop, if my Fibonacci number, let's just check this out, if that is equal to 55, I want to stop there, right? If that's true, then break, okay? That is a valid thing. I'm checking for specific value, and even though my loop says 1 to 10, I don't know which number it is. I want to get to 55, right? I want to stop when I get to 55, right? And so I won't do 55. You'll never see 55, okay? Because 55 won't print out here, okay? Or I can do this check. If I want to see 55, I can do that check up here, right? So at 55, after I do the console write line, right? I want to print out 55, and I won't do this anymore, okay? If I want to do that. Let's try this out and see what happens, right? Let's see what happens if I want to, I want to break out when I see 55. Now I'm telling it to go 10 times, right? 55 is like number 8, or number 9, I mean, right? So let's try this out. So this way, if we break out at 55, you'll see it goes right up to 55, but no other time. There it is, 55. And by the way, I can try, let's break at 34. Instead of breaking at 55, we'll break at number 34, right? So when it's 34, break, right? So break allows us to exit a loop early, right? Even though the loop tells us that it's gonna go for 10 times, it can break out whenever you feel like it, as long as you tell it to break at a certain time. If the condition doesn't meet, like let's say for example I said 35, we're never going to get to 35 with Fibonacci. It's never going to be that number, which means that I'm never going to be able to break out. Okay? So that's break. Break allows us to break out early. The other one that we can use is continue. All right, continue. I want to skip, if I want to skip 34, I want to do like 1, 2, 3, 4, 5, 8, 13, 21, and then instead of, when I'm at 34, I want to skip 55. I want to skip the next one, right? Then I can change the break to a continue. So what continue does is it stops operation of the loop and doesn't do anything else and skips to the top. It doesn't allow you to do anything. It skips to the next thing. So it won't do this part. It won't increment anything. It'll stop. So it'll go from 34 and then it'll skip, right? But it'll come back down here again. So what's going to happen? What if it skips at 34? What's going to happen? So it's at 34. It prints out 34. That's what it does. And then it says if it's 34, continue. What it's going to do next? What is it going to do next? What it's going to print next? 34 again. Because nothing got updated. This is the update part, right? This is the update portion, right? So continue basically skips the update, and it doesn't update that, and so now it prints out 34 again, another time, right? Here's a question. Will it ever continue? Will it be an endless loop? Here's what I've done. Look, let me show you. It'll do the first part. It'll do the first part. But then, oh my God, what did I do? Wait, I did 34 3 times, and then it exited. It would have been an endless loop, but my for loop has a limiter. It only goes 10 times. Otherwise, guess what? If it was in a while loop, it would keep going forever. I can't. The for loop needs the index. You can't get rid of it. This is the way the for loop works. If I use the while loop instead, right? Let's say if I made this a while loop, we can change this. If I said while, while my Fibonacci is less than, here, let's try this out. While Fibonacci, here's another way of doing it, is less than or equal to 200, I don't know if that makes any sense, then loop, right? So it's going to keep going until Fibonacci is around, until it's greater than 200. So if I did that, it's going to do 34 all the time. Like after 34, it's going to go 34, 34, 34, 34, 34. And it will ever reach 200? No, it's going to keep going forever. It's an endless loop, right? It's going to keep going forever. So this is the stuff that you can make happen if you're not careful, right? So continue skips anything that's behind after this and goes right back up to the top again. That's what it does, right? Yes.
So could you put the continue at the bottom?
I could. If I did that, then the update loop would happen. So if I did this and I said, if it's 34 skip, now what is it going to do? But look what it happens. It says redundant control flow jump statement. That means it doesn't matter. It won't do anything. It won't do anything because it already did the update, right? And then, well, it's telling you at 34. Well, it's never going to be 34 because once it's 34, it's changed. So it's never going to be 34, right? So, it's a problem. It's a real problem. And especially if you put it somewhere else. So continue, be careful with. Continue means, hey, I'm done. Go back up to the top again, right? All right, so that's continue. So break and continue. And that's what these two things do. It's really kind of interesting. One way it can really work is if you actually had an endless loop like this, where while true, you do one of these things, and you say, think of a number and type it here, and then you write a number, and then if the input is equal to quit or input is equal to exit, because you can enter anything you want, right, because it's a string, then break. That breaks the loop. Or if the number, convert the number if you can, and if the number is equal to 12, then you can say, I don't like that number, pick another one, and then it will do continue. So it'll go whoosh, right up to the top again. And then otherwise, if it's not 12, it'll print out the number and says, I like it. Right? Yeah, right? So it's an interesting way. There's a lot of control you can put in with break and continue. Now, I got to put my hand up and say this. These are sparingly used. Okay? I'm showing you them because they exist. So if you see them in a statement, you know what they do. Break breaks you out of the loop. Break breaks you out of a bunch of stuff. Continue continues back out, right? So be careful about this. It can mess you up and cause logic errors that can create endless loops or other problems, memory leaks. All right, so that's break and continue. Nesting loops, we talked about this. You can loop two things together. This is really cool. If I want an outer number and an inner number, I can do something that looks like this. Like I want to multiply the outer loop by the inner loop. I can do that, right? So you can nest loops together, right? So example, A is 1 and B is also 1. A times B is 1, right? That's what you're going to get there. And then it comes back up to the middle, the inner loop. The inner loop finishes first, and then the outer loop finishes. So the inner loop is going to go from 1 to 10. So A times 1, A times 2, A times 3, A times 4. It's going to keep going until it goes to 10, right? And then when B is 10, this loop terminates, and it goes back up to the top, right? And then there's a new for loop that forms that is now, B 1 to 10 again. It starts over again. So it's going to go A 1 times 1 times 1, 1 times 2, 1 times 3. It's going to do the timetables from 1 to 10. 1 times 1, 1 times 2, 1 times 3, 1 times 10, blah, blah, blah. Then it's going to be 2 times 1, 2 times 3, 2 times, then 3 times 1, 3 times 3, and 4 times 1, and it's going to keep through that to 10 times 10, kind of thing. And that's what it's going to be, right? So that's what this does. So you can make really cool constructs when you put one for loop or one loop instead of another loop, right? Because it's going to loop independently, right? A good example of this is row and column. If I want to move across a row and a column, I can have the column first, right? And then when the column gets to the end, I do it again. I go down one row, and then I go again. So the outer one would be the row, and the inner one would be the column. Does that make sense? Think about a spreadsheet. I have columns and rows, right? Or even graphics. I want to print out pixels across the screen. And I want to start at the top left corner, and I want to print to the right, right? And then I go down and keep going to the next line, and to the next line, and to the next line. Well, let's try that. So this is the last thing, and then we have to move on to actually other things. But let's wipe out Fibonacci. We did Fibonacci together, so hopefully you'll understand how to do that at home, right? And I want to do rows and columns, okay? So I want to do the outer loop. I want to do 10 rows by 10 columns, and I want to fill it up with asterisks, okay? So how do I do that? So I want to say so I'm going to say that the row, so int row, we're going to say that that's equal to row 0. We'll start counting at 0. And then row, as long as row is less than 10, so 0 to 9, right? Then row plus plus. Okay, and inside the row, we're going to say for column, int column, look, it's helping me out. Int column is equal to 0, where column is less than 10, column plus plus, right? And what I want to do is I want to print out, rows and columns like that. So I'm going to do a console.write, right? Where I'm going to write out an asterisk, right? And when I get to the end of the column, I want to go to the next line. So this is where I'll do a console.write line, right? So I'll go to the next line. So that'll print a block of asterisks 10 by 10. Does it make sense? Block of asterisks 10 by 10, a 10 by 10 block that I'm going to print out, okay? So this is kind of an inner loop. This is the inner loop. And the inner loop is going to reset every time it goes back up to the outer loop. Does that make sense? Because the outer loop, remember, this is what we talked about with scope, right? So guess what? Integer, this column only exists in this scope. Row exists in this scope and in this scope. That's where it exists, okay? But we don't even care about these two things. You could have used X and Y. All I care about is what I'm printing out. Column is this. But this is a very common construct, my friends. You're going to see this over and over again. A nested loop where I want to traverse row and column. Okay, I want to traverse row and column. Let's try and print this out and see what happens. I should get a solid block of 10 by 10 asterisks, right? That's what I should get. Let's see if it's true. There it is. Okay, 10 by 10 asterisks. Are we good? Are you understanding this, guys? Anyone not understanding this stuff? And the people online, yes?
Mine doesn't show up in row. It's more like it's this one long column of just asterisk, enter, asterisk,
Well,
enter.
Well, think about what I'm doing here. Maybe your code is different than my code. Check your code. Make sure your code is like my code.
Yeah.
Right?
Maybe it's something I forgot.
No, check your code. There's only one thing it'll do. It'll only do one thing one way. This is a specific instruction that I'm giving it, right? So, okay, here's something I want to do. Okay, here's what I want to do. I only want to print out this. I only want to print out the leftmost one, 0, and the rightmost one, 9. If my row is greater than 0, then I only want to print out the leftmost one and the rightmost one, but not the middle ones. Yes?
Mine is the same code that you have. It just comes out a bit differently. Maybe
Okay.
because we're using different computers.
It could be, but I doubt it. It may mean the way it looks might be slightly different. It's okay. Yeah.
I have the same problem. I have like it's not formatted in the same way, but it is doing.
Is it 10 by 10?
No, it's like 10 space 10 space 10. So.
Did you use a console write or a console write line?
Wait.
Check.
Oh.
Yeah,
I use a console write. So your code is not like mine. All right. There we go. Thanks, Garrett. So here's what I want to do. So here's the challenge. Okay, I want to, after the first row, if it's the first row or the ninth row, right? Then I want to print out all each of these is going to be a thing. Okay. However, if it's the second row, I don't want to print out all the middle stuff. I don't want to go from 0 to 9. I want to go only 0 and then the 9. I want to create a box. That's what I want to do. Can you do that? Can you make a box happen? So I want to print the top of the box, the sides of the box, and the bottom of the box. Nothing in the middle. Can you think about some code? This is challenge. By the way, this could be eerily similar to something that I put on a test, right? Do this with your code, kind of thing. Make it work like this, So think about it, right? So how can you do it? We can use if statements, right? We can test to see what it is. So we can say if row is equal to 0, right? Or if row is equal to 9. Those are the two conditions. Then we want to do this. We want to do this, right? We want to do this. So that's the only time we want to print these out. If it's row 0 or 9. Otherwise, right line. Let's try this part first if it's a condition. So I put an if statement around my for loop. And then if I run it, let's see what happens now. I should get a weird thing that happens. Let's see what happens. Right? Let's try it out. And I get this. I got the top of the box and the bottom of the box, but I didn't get the beginning or the end. Okay? So now let's think about the next case. The next case is if it's not one of these. Well, that's the else statement. So let's do the else statement. And there's some tricky stuff we can do here. Do I need a loop for this? That's the question. And the answer is probably not, right? All I can do is I can do it row by row. I don't need a loop for this. I can do a console.write line. I mean, this is cheating. I could do a console.write, right? And I can put in this is 1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. That could be the other one. I can do this. Look, right? That's cheating, right? I could do this, right? And if I did that and press play, let's see what happens, right? I don't know if I did it right. Maybe I didn't, Yeah, I didn't quite do it right, but that's okay because I can fix that. I made a D. That's what I made. So I can just take one of these away and I can press this. And now we've got what looks like a box, right? I did a box. Guys, you can do any kind of crazy stuff you can think about with for loops, all right? And with while loops, yeah.
I'm kind of running into an issue here.
No issues.
You know those double lines there between the rows?
Yes.
Whenever I type those in, I always get an error. I've tried this several times. Every time it results in an error.
Okay, maybe you got the wrong lines, right? Maybe you got the wrong lines. Can someone help him out? See if he's got the right lines in there, the pipe characters. How about my friend who's not who's hurting today? My friend who's like full of pain, who came in and who hasn't done anything. Hey, my brother. Him, yeah. Yeah, I'm talking to you. Yeah. Can you help my friend out here? He's having a problem with his pipe character. This way you're doing something. You're my TA today. Come on. Dance, buddy. Dance. All right, there we go. So here's something. So can anyone think about another way of doing this? Instead of me doing this, could I have done this differently? Is the answer. Is the question that I could have asked. Could I have done that with something that is this, right? Right? So let's think about this. If it's not that, if row is not this, could I have done something in here to make this different, And there's a lot of ways to write this thing so that it's less code than this. I want you guys to experiment and see if you guys can do it, okay? Not today. but another day, try and make different shapes. Try and make a T. Try and make all the letters in the alphabet with your characters, right? And try to do that programmatically, right? And see if it can work for you, okay? All right.
Why does it not say that?
Wait. Sorry, how many spaces are between?
You got to experiment, my friend. You got to experiment the spaces, right? All right. All right. So, are you anyone else unclear about what I'm doing online? Because I'm trying to make it so that we can do a lot. I'm trying to show you here. There's a lot of powerful things you can do inside of loops, and we can use some of the things we already learned about last week to this week, right?
This part is like, it just doesn't work.
Well, we're going to make it work, buddy. Don't worry. I'll come over and make it work for you. All right, so let's move on. We need to move on now. So let's get to the next part. So we talked about nesting loops and how powerful they are, right? We talked about how you can do current row and current column. I kind of did this little thing right here for you, so you can print out rows and columns of asterisks. But we have a bit of a problem, and I want to get to the heart of it today because we have a lot to cover still, right? And one problem that we have right now is convert to int 32. Convert to int 32 is giving us an issue, right? If my user enters whatever they want, right? If my user enters whatever they want, then they can enter garbage instead of like a number between 1 and 10, as an example, right? We don't want this, and we want to be able to use some kind of another statement. So there's something else called a try-parse that we can use. We talked about parses. There's two ways to do it. You can do convert or parse. Remember that? It was when we talked about the converting way back in the beginning, almost the first day. We talked about like converting to, right? Or the second day. I think we had in the second week, we did like input, right? And in input, we said like you can convert like your read line into an integer because we want to convert strings into some numbers in order for us to deal with them. Anything that's in the user interface is a string. How do I do anything? Well, what happens if you're trying to convert something into a number, a string that's not a string number? It's not a 1. It's like A, B, C, D. It's going to crash your code, right? Well, there's another thing we can use called try-parse. Try-parse basically is a way of using input validation, okay? Try-parse is a little bit complex, and I got to talk about the format of it, okay? Here's what it looks like. There is the thing that you want to try. I want to try this string, whatever that string is, right? And then there's this funky out character, okay? Out character. And it's going to go to someplace else, another integer that's not in here, okay? Out means I want to refer to, reference this integer. So it might look like this. Here's example 1, okay? The input is 42. It's a good number, all right? So we can do the input is the string. That's the one we're going to test with, input, right? The number is where I'm going to store the number that is valid. If the number is valid, when I convert, I'm going to store it here in this number. But I got to reference it here with an out statement, an out keyword. Okay, this is just syntax, guys, okay? And then, if everything is good, then is valid, my is valid is true or false. So remember what's going to happen. Try-parse is going to try to convert. If it is able to convert, then it spits out at the end a true or false. So is valid is going to be either true or false, depending on what I do here. So here, is valid is true, and number becomes 42 because try-parse tries to take the input, which is 42, string 42, and convert it to a number. When it does, when it successfully converts it, it stores it in this variable, which we defined before. Okay. Moving parts, all right? A little bit complex, but what it does for us is this. It prevents a user from giving us a number that is invalid, okay? That's what it does. So example 2, here's what happens when you get invalid input. Let's say the user types in hello, which is not a number. You can't convert hello into a number, right? There is no number hello, right? So it's going to try and convert. It says, hey, take that number, try and convert. It's going to fail. If it fails, it's going to make invalid false. That's what it's going to be. And the number is going to be 0 because number by default, any integer is initialized to 0 by default. Okay, that's what happens. So this is try-parse. How can we use it in our code, right? Well, it's really good when we want to read a number like this, where we wrap it inside of a while loop. So here's an example. I have two numbers now. Instead of one sentinel variable, I have two. I have career choice, which is a number, and I have is valid, which starts off as false. While is valid is not true, that's what this is saying. While not is valid, right? Then enter a number, read it from the console. Here's the input string. Test that this string is valid. If it is valid, store the number in career choice, right? And have is valid is true. It's going to loop up to the top and check to see if it's not valid, is it false? And if it fails, it's going to exit the loop. Otherwise, it's going to keep checking until the user enters a proper number. This is input validation for you, okay? So how do we use this thing? This is part of your in-class exercise 4, by the way. How do we use this thing in our code? Okay, let's get to in-class exercise 4, because I know people are going to be real nervous because we're getting on to the last part of the class, and there's lots to cover, right? Yes?
Okay, try.
Is this related to what I'm talking about here?
I wasn't talking about that, but then.
I have to move on, Damien. I have to move on. Don't worry about what you're doing. That was just an example. We have to move on with what I'm doing here, which is more important right now. All right, so let's go back to this. So what I'm going to do is I'm just going to comment this out so we can talk about it for people later, right? I don't need no need this. Okay, so here's challenge number 1 for your in-class exercise 4. Challenge number 1, okay? I want to uncomment all my in-class exercise again. This stuff here. I want to uncomment it, please. So take away the top and take away the bottom and check it. Comment out that little test we were doing, okay? Let's comment it out and let's run the code and see if you still get the same thing we got before, which is a number between 1 and 6 with a user, okay? So it's going to ask me for, is it going to crash?
You just uncommented all the stuff.
Yeah, but it also crashed. Did it crash? Oh no, it's just here. Here it is. So it's going to say Tom, and then I'm going to choose random, and it's going to give me the random number and press enter, right? I want this to be a forever. I want this to be a forever loop, right? I want this to be a forever loop. And the way I can do a forever loop is, and when I enter certain elements, I want to stop, okay? So I want to skip down here to your requirements right now for your in-class exercise 4, just really quickly. I'll come back. We're on page 27, but don't worry, okay? I'm going to come back all the way to that in a second. So back up to ICE 4. So far what we've done is we've done our Git setup, all right? And we've renamed our solution. So right now you have 2 marks if you followed along, okay? Up to here. You've already done this stuff. Git cloning and renaming, okay? Here's the next part. The while loop. I want to do this while loop right now. And here's this thing that I'm talking about, which is I want to do this, right? Where I kind of get this thing inside the while loop. Console next key. This is interesting. So next key would be the name of the variable. Console key, right? What it is a special variable that I'm talking about. I'm giving you this, right? I don't want you to find this out. I'm telling you this is what you need to use, right? Console key. Console key basically looks at, hey, what key am I hitting on my keyboard? Which key is it? Like A, B, C, D, whatever. It's going to record the key, right? There's 2 ways to record the key. It can record the actual key, doesn't matter lowercase or uppercase, or it can record the key character. It's up to you. Those are the 2 things it can do. So when you do a console read key actually gives us information that we just haven't done so far. We haven't used so far. So far, we've been ignoring it. We just say console read key, and then if we press any number to continue, and stops the program, right? But console read key actually gives us more information, right? It gives us actually other things. And so this is the condition of the while loop. This is what I want to do with your while loop. Let's put this while loop in play. So I'm going to copy these 3 lines, please, from the PowerPoint. Please do that. And I want to go back to my code and way at the top, and I want to do this just before I ask for the character's, just before I declare the character's name. I want to put all of this inside of my while loop. So right here before the character's name, I'm just going to put that while stuff in like this. Okay? Now I got a problem. Because I need a bottom curly brace, right? This bottom curly brace has to be somewhere. It's got to be right at the bottom, guys, like another curly brace at the bottom. So that means way down here, right? I can put another curly brace right here. Notice that there's like a curly brace that's missing. I could do that. Or here's something you could do. I could end the curly brace right here. I could do that right here. I could do this right here, right? And then I could copy paste or cut paste all this stuff and put it inside of here. But this while loop has to wrap all of my code, right? I want to put it inside the while loop. So how do I do that? I'm going to grab all of this. That's one thing I can do, all of this code. It's going to go all the way to the bottom, right here to this part. And I want to cut it, Control X. And I want to go inside the while loop and I want to paste it, Control V, right? And now, look what I got. I got all this stuff is inside of my while loop. Okay, so I took everything that I had. You can actually minify the while loop, so it looks like this. This code is the stuff that we were practicing together. We don't need this anymore. This is just my row and columns information, right? But what I have, you can collapse your Visual Studio Code right here. Notice there's a little collapse button, a little expand and collapse button right here. I can expand it and collapse it right here so you can see it, right? It's right next to the while loop, right? So everything is in the while loop right now. Are you with me? Okay. Now, when everything is in the while loop, we have to terminate the while loop. Right now, it's going to be a endless loop because there's nothing that we're terminating. How do we do that? Console next key right now is none. We're looking for Q or escape, right? That's what we're looking for. So way back here at the bottom in the first time, when we're getting input, right? We're getting input. At the bottom, this is the first escape part. Look, my default, when you enter an incorrect character, this is a great place to escape because I have a console read key. This is my first console read key, right? Where I can say something like this, right? Remember the variable name that we're using, just to let you know, right, is next key, right? Next key. So if I go back all the way to the bottom and I say something like this, next key is equal to console read key, it's going to give me an error. I have to append that information at the end, and we're going to put in a key at the end, like this. Console read key, key. Okay? So instead of press any key, we want to give a message. Press Q or escape to exit. That's what we're going to say. Press Q or escape to exit. Does that make sense? So next key is going to hold the value of the key we're pressing. We're going to press a key. Q, next key is going to hold that value. That's what it's going to be, right? And once it does, it's going to store it. And it's going to basically, now this is break. Do I want to use break here? What can I use here? Because I don't want to do something. I want to flash back up to the top. What do I want to do instead of break? You said it. Continue. Let's change break to continue. So what this does is basically going to say this. Get input from the console, and if it's a Q or anything else, if it's a Q or an escape, escape, stop, right? If it's not a Q or an escape key, let's do that again because you typed in the wrong thing. So it's going to go now, it's going to allow us to keep entering data until you have a number between 1 and 6, a proper number, all right? And then at the bottom, here's the next time we can stop. Down here, we can do the same message. Press Q or escape. This is at the bottom, right? The way at the bottom to continue to exit, right? And then we're going to do a next key. One sec. Next key is equal to this key, and then continue, right? Oh yeah, continue. Sorry, what were you saying? Like what? What do you mean? Oh, don't worry. That's me. Don't worry about that.
I don't need to write that line.
No. Just if you have true. Intercept is my code hinting. That's what it's doing. All right. So let's try this out and see what happens if I did it this way. If I press play now, let's see what it does if I'm in endless loop, right? Because I'm in endless loop until I press escape key or Q, right? So let's try this out. So here's my name, and then here's random, and then I get to the bottom and I press space, and I'm back to the top. And I press Tom, and I press another random, and I press space, and I'm at the top. And I press Tom, and I press Q, and I press enter, and now I die, right? So why did I die, right? My career choice killed me, right? Let's try this. We're gonna fix this problem. Let's try this again. Because career choice was asking for 1 to 6, and I gave it a Q, and I killed it. All right, let's try this out. Tom, and I press 6, and then I press Q, and now I escape. Okay? And maybe what we can do is, instead of doing this, we can clear the screen when we escape too. So we can kind of do something like this. When we come to the bottom, and I'm done, I press the right choice, and I print out my character. Then, after they print the key, then I want to clear the screen. So I can do some kind of a console.clear, right? Which will clear the screen. And then I want to continue. Let's try this out. So I did that here, and if I go to the top, and if I press play, I press Tom, and then I press my number, and then I press a Q, and I'm back to here, right? Or I start Tom again, Tom, and I press the number, and I press here, and I press spacebar, and I'm at Tom, and I press the number, and I press spacebar, and I keep doing that over and over again. This is what your code should look like now. Let's put this up on GitHub, all right? Because this is part of our in-class exercise, all right? So let's try this out. Git add dot, git commit -m, and we'll say wrapped previous code in a while loop. Git push. Guys, you have access to my GitHub repository. You can look at my code right now. This is a we do situation. We're doing it together, right? So you can always look at my code if you want to catch up, or if I did something that you didn't compute. Yes.
So before we do this, all it has to do is just it just has to keep repeating itself.
Keep repeating forever, right? But what it's doing is, look what it's doing, right? At the top of my code, here's my code. Let's take a look at it for a second, one more time. At the top of my code, all I did was I copied these 2 lines from my PowerPoint slide deck. I did this, look. I did this, I copied these 2 lines. I created this while loop, and then at the bottom somewhere, where you're asking for a read key, you need to do this. Okay, I'm telling you where it should go. Okay, so that's the first thing. So this is worth 3 marks now if you did all this with me, if you're with me, okay? Here's the 4th mark, all right, for your in-class exercise. I want to do the try parse. Okay, this is the try parse. Remember I just talked about try parse? I want to put this idea in the entry place. Okay? Take a look at this. This is a drop-in replacement for what we have. Drop-in replacement, my friends. Okay, let me show you. If I go back to my code, here's my code. I ask for career choice to be converted to N32. This is what's crashing. If I enter an ABCD right now, right? Let's try this out. If I enter an ABCD right now, so if I go Tom and then I choose a career and I said like ABCD whatever, and it's going to crash, right? Because it doesn't understand that. It's trying to convert that thing into a number, and it can't. It doesn't know what to do, right? So that's not what I want, all right? I want to replace this area here, this career choice stuff with my selection with a proper thing. So here's some code that I've given you to try. I can have a Boolean that is valid, right? And I can run a little while loop inside of my while loop, right? Where the while loop will keep asking me for input until my is valid is true, okay? So remember, career choice is the thing that I want out. I have to put that. So let me copy paste it. I'll do a drop-in replacement for that stuff right here. So here's, I'm going to copy this code, right? Go back to my code and get rid of this, just this, all right? And then press enter, press paste. Now, you're going to see it's going to say enter your selection. It's going to declare is valid. It's going to start off as false. And it's going to say if it's not true, then it's going to say enter 1 to 6, right? Now here's something. Do I need your selection? I don't need this anymore. I can get rid of this. I don't need your selection anymore, right? It's just going to say enter 1 to 6, right? And then it's going to say if everything is good, it's going to skip this part. And if everything is good, it's going to come out of this loop and it's going to continue. If it's not good, right, then it's going to say invalid entry, try again. Let's try this out and see if it works. All right? Again, I dropped in that code right here, right? So let's see how it works. So Tom, right? And if I press in 7, it's going to go, bam, incorrect choice. Please run the program again. Wait, what? What happened? How come it did this, right? It didn't go through my while loop. How come it didn't? How come it didn't do this while loop, right? I mean, before I went to the switch case, it kind of skipped through this thing and then went down here. It says, so let's take a look at this. It says, name is valid, does not match the ruled local variables. Okay, well, if it's not as valid, it's going to go here. It starts off as false. If it's false, right, is this going to work? What if we said if it's valid, that's not true. If I made this true, and if it's not is valid, if it's not true, if it's false, then do this. So if I change this to true, will this part of the loop run is the question, right? Will this part of the loop run, right? Let's try this out. So let's try this a couple times. We don't want to take you too long today. So it prints out Tom. And then I get to this. It says, you entered incorrect choice. Please run the program again. It skipped that whole thing. How come? Right? Well, it says, as long as it's not true, then do this. It's true, so it didn't do any of this. You see what I'm saying? If I make this false, let's try this out again, right? Let's try this out again. There it is. Okay, so here we go, Tom. Okay, and if it tells me enter 1 to 6, if I enter 5, it does tinker, no problem. And I can kind of go back up to the top and try it again. If I enter 6, it does random, right? And if I enter 7, it says, you entered incorrect choice, please run the program again. Wait, something went wrong. It should have done some other part of my loop, right? It actually is working the way I want it to, right? But it does 7. So 7 is not invalid, right? Which means it's going to skip all this and go to this part right here, which is going to say you enter an incorrect choice, because there is no 7, but it understood my choice. Okay, let's try and enter an invalid value like A, B, C, D, whatever it's going to be. Let's see what that happens then, right? So again, I'm testing it before I put it up on GitHub, guys. So Tom. Okay, so now I'm going to enter blah, 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 and press enter. It's going to say, bam, invalid entry, try again. Blah, 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 bam, invalid entry, try again. Blah, 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 and 1. Blah, no, but if I type in 1, no problem, it'll do. So the try parse, what it's doing for try parse is it's trying to convert. If it's successful, it will convert it, store it into career choice. If it's not successful, it's going to ask the user again through another internal while loop. So now we have 2 while loops. There's one at the top that takes up the entire program, and there's one down here, this little choice. We're going to keep spinning that up over and over again until you enter a proper choice. Okay, that's what it's doing. So let's take a look at that. So that is right here. Right here. So this is the inner while loop. So this, some comments, inner while loop, my friends. This is the inner while loop. Okay? This is the outer while loop. Right here, right? Outer while loop, okay? There we go. Inner while loop, outer while loop, it's working. Let's save it and let's put it up on GitHub. Because now we added another thing. So we're going to say git add dot, git commit minus m, and we'll say added try parse to validate input entry. Okay, and git push. So that's my next commit. Okay, there we go. Okay, my next commit. Okay. The next one we're going to talk about in a second. Last part, my friends. Last part, I swear. Last part. So we talked about triparts. Last part is methods. What the heck are methods in C#, right? I want you to think about this as reusable code that can be called, okay? So bear with me. I know I'm running a little late, as normal. So I want to talk about first this last thing, the dry principle, all right? The dry principle. The dry principle states that, don't repeat yourself. That's what it stands for. It's actually an acronym. Don't repeat yourself, right? If you're repeating yourself ever in the code, in your mind, you got to think about something is wrong, right? I can do something to not repeat myself, right? And so imagine if I did something like that looks like this, right? You can clearly think that this is repetitive, right? Because I can write this in a different way. Instead of writing it like this, hello, the hello part is the exact same. Hello, hello, hello. But I'm swapping out the names. I could use a variable for the name, and then I don't have to use 3 statements. I can do 1. And maybe I can use a for loop or some kind of while loop or input, right, to input those names. So I don't have to go, hello, hello, hello. I don't have to do those things. And I'm sorry, this is a campy note, like I said here. Programmers don't want to be wet, which means you don't want to write everything twice, okay? If you're writing everything twice, something is wrong. Now, guys, I know this is a funny thing to say, and I'm talking about the dry principle today. Today, I'm not going to take marks off, but going forward, because you've learned about for loops and you're learning about methods today as well, a little bit, right? If I see places in your code that can be reduced, right, then I'm going to take marks off. Yes.
When I'm doing the coding, I can't do the command thing that you do, but I can push it through the div comp thing on top, where I can just keep pushing it. Is that?
I mean, it's not you. It's just going to slow you down at one point, and especially now after we do branching. But
Yeah, I don't know what it is with that computer.
well, we're going to have to fix that. Make an appointment with me to fix your problem.
Yeah, no problem.
All right. So dry is cool. So we want to use something called a method. So I want to think about a method as a reusable block of code, similar to what we've done so far with for loops and with while loops. It's reusable though. So here's an example of what it looks like. The return type. Methods have a return type. And we've already seen this. You know what the method that we're using right now? WriteLine. That's a method, right? WriteLine returns a string. I showed you this before when we looked at WriteLines, right? So a method name, and then it has optional parameters. You can pass in some value to the method. And it has a return type, okay? Potentially, it's an optional return type. So there's a bunch of different returns you can put in here. You can put an int, a string, a bool, or whatever, even void. And whenever you see void, we've seen this before, by the way. If I go back to Visual Studio really quickly, you can see that at the top, our main is static void, okay? So void means that main returns nothing. It doesn't return anything back. It's a function. It's a method. Okay? I just said 2 things, function, method. And a lot of times people see methods and functions as the same thing. All right? So what these things are is a place that I can write code and I can refer to this function and it'll return information. So here's what functions can look like. You can declare functions like this. Here's an example. I have a say hello function. It's inside my program and it's underneath main, a whole other function, right? That looks like this, and it has to have this static thing too, right? I can do this. And then I can call say hello anywhere in main by using just this value here, the name of the function with parentheses. That's how I can call this. And this is fine, but we're going to talk about a different kind of function because today we're not doing functions. Today we're talking about loops. Functions we're going to cover again, or methods, week 8, all right? But I want you to know about methods today because there's one little cool thing we can do with methods that can really reduce our code today. Remember all those like D10 next, D10 next, D10 next? Imagine if I had a function that did all that in a for loop, right? This is where I'm going with this. So here's another way of doing a function. You can have a function or a method and it can be inside of another method. Okay, remember? Container within a container within a container. We've done those things already. If statement inside of an if statement, switch case inside of a while loop, a while loop inside of a while loop. We just did that just now. You can do a lot of those constructs to create really complex code, okay? So I can also make a function that's inside of a function, and this is called a local function. Local function. Even though it's the same as main, main is considered a method because it belongs to the class. You're going to learn about that next semester. But say hello, in this case, because it's inside of main, a function in a function, it's just considered a local function, okay? So we're going to call this a local function. So what we can do with it, if we can send some parameters into a function that looks like this. If we can say that a parameter is passed into a function if it's put inside of the parentheses, like this, okay? So I can pass in strings or whatever. For today, we're not going to pass in anything, but I've put this slide up here because if you're going to read this on your own, just so you understand how functions work, homework, guys. I'm going to ask you about this next week, okay? Again. But for today, you want to know that methods can take inputs. Methods can also have outputs, like this. I can have a method name like add numbers, and I can have two inputs, the left side and the right side, A and B, and they can add A and B together. The return statement, the return keyword, returns out or copies out the value that this evaluates to, and it must be integer. Because we've stated that it's an integer, then these two things in here must be an integer number that we're returning back out, okay? So that's the return type. So here's an example of something that we could do for roll 5d10. My friends, this is your homework for ICE 4. I want you to implement this function, roll 5d10, okay? So here's what roll 5d10 does, this function, okay? It starts off with 0. Don't think about the name right now, okay? Don't think about this roll 5d10. Think about what it does inside here. We just learned about loops, right? Here's a loop. I'm going to take my total, which starts off at 0. There's going to be 5 dice, 0 to 4. We're not going to go to the 5th die because that's the 6th die, right? 0, 1, 2, 3, 4. That's 5 dice, right? And then I'm going to die plus plus. The total, which is starting off at 0, I'm going to add in a random number between 1 and 10. So the number starts off at 0, I add the first die. I add the second die. I add the third die. I add the fourth die. I add the fifth die. And then my for loop ends. When it does, I have a total. That's the total that I want. And I want to return that total back out, right? And then roll 5d10 actually has the value of the total. So what I could do, and this is your homework, right? What I can do is instead of having all of this mess, what a mess this is, if I have that local function somewhere anywhere inside of my main, but outside of my loop, it has to be outside of my while loop, okay? Cannot be inside my while loop. If I have my roll 5d10 in there, right? And if I recommend also that this statement right here stays where it is, you can keep it where it is. Don't put the random statement inside of your roll, all right? Because then it's going to actually look at this. You can get the same number, right? Because this is the seed, right? So leave this here, but these can all change to look like this, okay? It can change to look like roll 5d10, like literally like this. That's it. Now, there is no 5d10. You have to implement this. So that's your challenge, okay? That's what I want you guys to do, okay? I want you to do that, and this is the function that you're going to use. I've just showed you. This is an example of rolling dice when using a local function. So this is the example that I want you to use. Pretty simple, okay? One thing else, calling methods. This is the way you would call it. Agility is equal to roll 5d10. That's how it would work, okay? Roll 5d10 now is going to have the value of whatever it had inside. So one thing that I want you to look at is how it's done. It's done like this, okay? So when you declare a method, and I kind of went into details here for you, so it's not undoable. The first thing that you do, right, is when agility is calling roll 5d10, it jumps to the method, wherever that is, okay? It jumps up to here. Then it does all this. It resolves all this stuff. That's number 2. And then it returns back out the total. It returns it here, right? And then it assigns it to agility. That's how it works, okay? It's very nice and easy. Methods are very powerful, my friends. With methods, we can do anything. In fact, we can program almost anything any code you've ever seen just with the stuff I've just given you, with methods, all right? Now, we use classes because it makes it easier, but methods definitely are a way of programming. In fact, it's called functional programming, which is something that you can do. So your tasks, I'm going to jump to your task now for a second. We did this part, but you need to implement the 5D10 local function. That is yours to do. Define this helper function inside of main. It has to be outside of the while loop, okay? Just letting you know. You want to use a for loop and add 1D10 to a total. I've given you that whole piece of code, really, at the end of the day. Okay, if you want to make your own, you can do that, all right? And then what you want to do is, for the second part, is roll 5D10 in a random career case. For example, it would be something like your core attribute, agility, is equal to 5D10, all right, instead of the current code. This is a real easy one to do, but placement of your roll 5D10 is the key point. Making sure that it works, testing it to make sure it does whatever you're doing now, okay? I also have one piece of homework for you to take away. It's called branching and merging. I'm not going to discuss it here today, but I want you to read about it. I put it in here to talk about branching and merging. And next time we get together, which is in class exercise 5, we're going to use branching and merging whenever we do a feature, okay? That's what's going to happen. So that means that instead of doing what we're doing right now, which is pushing up to GitHub every single time, we're going to create a new feature branch. We're going to work in that feature branch, and when we're done, we're going to push it up to GitHub. So please read this section. I'm not going to go through it, but please read this section before next week, okay, because it's required. And I want to do one more thing before I let you guys go. I'm sorry. I know you guys will run. You have the bus. I'm so sorry. If you want to go, it's okay. I've recorded this, right? So here's one thing I want to tell you that I want to talk about, which is ask yourself how you guys are. How you guys are. How are you guys? Are you guys okay? You got a lot of work happening. I keep asking this question every week. Think about the amount of workload that you have, right? I told you guys before, as students, you're not regular people. I'm not lying to you, all right? I'm telling you, there's a lot of stuff. You're probably feeling death of a thousand cuts about now. And we're about halfway to the halfway mark. We have 3 short weeks before our midterm test, where I'm going to give you a piece of paper in your hand. You're going to put your bags at the front, no phones, no nothing, and you're only going to have your laptop and my instructions, and that's it. And you're going to have to do what it tells you to do, right? We're 3 short weeks away from that. So if you're really struggling with understanding the concepts right now, make an appointment, okay? If you don't make an appointment, there's no, I don't know how to do GitHub 3 weeks from now. There's no, I don't know what happened, sir, but you know what? My computer's not doing what it's supposed to do. There's none of that. You, by mid-semester break, or before mid-semester break, when we do our mid-semester test, you need to know everything that we've done up until now, up until then, actually, okay? Please book time. That's it for me, guys. Thank you so much, and good luck, and people wait around. I can answer some of your questions.